Okay, we're back with another question from one of your classmates, and this question is about solar panels. And these solar panels are 1 square meter. That's the surface area, so move that up. And if the solar panels are working at 100% efficiency, we are told that each 1 square meter solar panel will generate 1,000 watts of power for each panel. And so let's write that down and move that up. Okay. Now, I want to write what a watt is. A watt, this is important, a watt, I'm abbreviating it, it's W-A-T-T. 1 watt is equal to 1 joule. A joule represents energy. 1 joule per second. Okay, so a watt is 1 joule per second. So let me move that over here. This is just to let us know what a watt is, 1 joule per second. Okay, then it gives us an example, and it says that if our panel works at 10% efficiency, then we take 10% of 1,000 and we get 100 watts. So the amount of power from our 1 meter squared panel is 100 watts when we're working at 10% efficiency. Now let's do the problem. In the problem, we're told that the panel is working at 60% efficiency. Well, if it's working at 60% efficiency, then we will take 60% of 1,000, which is 600 watts. And it gives us 600 watts of power each hour. This is, by the way, each one of these is this occurs in 1 hour, how much power we get in 1 hour for the panels. This is 1 hour, this is 1 hour for the panel, and we'll switch this to blue. And in 1 hour, that's a 1, our panel gives us, in our problem, it gives us 60 watts in 1 hour. And also in the problem, it tells us, though, that we do this for 3 hours. This goes for 3 hours. And the question is, how many joules of energy do we get from the panel in 1 day? Well, if we get 60 watts, 60%, which is 600 watts, excuse me, a watt is a joule per second. So we get 600 joules per second each hour. Okay, this is our 600 watts. Our 600 watts is 600 joules per second. See, this right here. This represents the 600 watts you have here. And the joules per second, well, that's a watt, and that's because I wrote it up here. A watt is a joule per second. Okay, so we get this for 3 hours. So I'm going to say this is in 3 hours. So we have to multiply it by 3. And I'm writing these all as fractions. So what I'm saying here is that this 600 watts, or 600 joules per second, is what we get in an hour. So we must multiply it by 3 hours, so we get 3 times that. But we want this in joules, and so we want this hours to be converted to seconds. So I'm going to do that now by saying I really want this to be the seconds that are down here to go away. So I'm going to convert the hours. I have hours up here, and I want to put hours down here. So if I put an hour down here, I know that 1 hour is 60 minutes. And what I'm trying to do is find some unit of time that's going to cancel out the second. Well, minutes doesn't do that. So I need another fraction here. And I'm going to have minutes in the denominator, and 1 minute is 60 seconds. And so now what you see here is that these 2 hours cancel out, the 2 minutes cancel out, The second here and here cancel out, and the only thing left is the joule. That's what we want. So let's do that. So I'm going to say that this second right here is canceled out here with this second. This hour is canceled out here with this hour. This minute is canceled out here with this minute. And we are left with just a unit of joules. And so we end up with 600 joules multiplied by, and this is what's left, multiplied by 3, and multiply that by 60. And you can do this on your calculator. And multiply that by another 60. And what do we get? I don't know if I can move this over. I can't. Okay. And what we get here is, oops, let me get that pencil up. Okay, 6,480,000. Okay, and another way to write that is 6.48 million joules, because these are joules. Let's put a J right there. There we go. And this is per day. This is how much we get in one day, because it's 3 hours in a day. And there's our answer to the first part of this problem. Okay, I'm switching to black. I'm doing the last part of the problem, and it wants to know what is the average power in watts that the panel produces in a day. Okay, so in a day, we know that the panel produces 600 watts per hour. So if we multiply that by 3 hours, we get the total power in a day. If we divide that by the number of hours in a day, which is 24 hours, we will get the average power per in a day. Okay, and when we do this, the hours will cancel out and we'll just get watts, and that is the average power in a day. And that works out to be 600 times 3 divided by 24. That's our value, and this is watts, the average watts in a day. And we can use our calculator here, and when we do, we get 75 watts of power is the average power in one day. So here we have two answers, and our first answer, we'll box our first answer in black. It's written in blue. There's our first answer. That's how many joules per day. And our second answer is the average watts per day.